Hi, I'm Tanish, and this is part 3 of a series where I solve systems of equations with matrices with different methods. In this video, I'm going to use Cramer's rule to solve them. So the main thing about Cramer's rule is that if once you have a system of equation, x variable will be equal to dx over d, the y will be equal to dy over d, and the z will equal to dz over d. Well, we're obviously dealing with matrices, so the d over here represents the determinant of the coefficient of these this if I convert it to matrices. So no matter how many variables you have, you can always make it into the equation. You have if you have like w, it'll be equal to dw over d, or something else, depending on what variable you have. So what is d and what is dx, dy, and dz? In this version, only convert the coefficients into matrices. Three, 5, -2. Now that we did that, I'm simply just gonna keep the 1, -3, and 4 here. It's because it'll be a little more accessible. And now for d. So d is basically just the determinant. The determinant of the coefficients itself. We have 2, -6, 1, 3, 5, -2. For Cramer's rule, you do have to know what determinants are. So I'm just simply solving for the determinant. So you can solve it your own way, but I'm just doing it my way. Anyway, finally got it. So it's -6 times -2, 12, then plus 9 plus 10, minus 18, minus 5, minus 12. You'll end up getting -4. I solved for the determinant for the coefficients, and I got -4 as the determinant. And so that is what d is. So the d is just the determinant. Now, what is dx? So dx is essentially the same matrix, except I swapped the x row, with the values after the equal sign. So I just swapped this entire thing and put it here. So I'll end up with a matrix. It'll still have these rows, except I just swapped this one for the in the x column. So -1, 1, -2, 3, -6, 5, and then I swap it out, so I have this here instead of this. So 1, -3, 4. Simply to highlight it, I'm just gonna okay. D of x is, you probably guessed it, the determinant of this new matrix. So I just 1, -3, 4, 3, -6, 5, 1, 1, -2. Let's do this. So 1, 3, -3, -6, 4, 5. So let's quickly just solve this. 12 plus 12 plus 15 minus 24 minus 5 minus 18. So d of x, it's weird. D of x is equal to -8. So we got d of x. Let's get d of y. And again, instead of swapping the x row now, you swap the y row, this row, with the values after the equal sign. So I'm going to put them in. So I'll have the same values before. So -1, 1, -2. I'll have the x column 1, -2, 3. That's the same thing as the original one. Now we swap the y row with the values after the equal sign. So that'll be 1, -3, 4. Let's resize this. All right. Let's find the determinant of this, because that's what d of y is. It's 6 plus 3 plus 8 minus 9 minus 4 minus 4. So d of y ends up being 0. Let's say d of z. It's more obvious now, so I end up switching the z column for the values. So I'll still have the x column 1, -2, 3. I'll have the y column 3, -6, 5. Now I just swap out the z column with 1, -3, and 4. 1, 3, -2, -6, 3, 5. And we solve this out. 12 plus 9 plus 10 minus 18 minus 5 is 12. dz, dz is equal to -4. Okay, we got dx, we got dy, we got dz, we even got d. So we have our original equations here. Okay, we have the original equations. All we got to do is plug them in and get our actual values. Since x is equal to dx over d, since dx is equal to -8, and d is equal to -4, the answer will end up being 2. X is equal to 2. Then y is equal to dz, no, dy over d. So dy is equal to 0 over -4. So the answer is 0. I apologize for making any errors. It's like 3 in the morning right now. And z is equal to dz over d. dz is -4 over -4. And then we get 1. Z is equal to 1. Our answers is 2, 0, and 1. Cramer's rule is definitely my favorite because if you're good at determinants, you can easily solve this really quickly. Rather than all the other methods, just a mess. Inverse especially, just I don't like finding inverses, so I don't prefer it. This one is a lot of writing out, depending on what kind of matrix. The matrix I gave you is one of the easier ones. You might come across like the 4x4s or just values with really high values. This one you can't go wrong. Simply determinants. Yeah,